do you see a screen with two robots now?
Oh, hold on, I gotta get it pulled up here.
Okay.
Let's see, where is it? There we go. Okay, I've seen robots on the screen now.
All right, cool.
On the big screen now. On the big view, and then small window is your code.
Yes, that should be it. Okay, cool. So we're back. And now that we've trouble solved problems, we can come back and do a little coding or do a little battle. So we're gonna call match 1 a draw, and we're gonna let him go. Match 2, go. Oh, they're kind of stuck. Nope. Oh, that is new. That is definitely new. Batteries eventually fill out. That is crazy. That is kind of crazy. I'm gonna get here, and this is what we've been waiting for, was the batteries to fly out. So I think that the fair ruling on that was we let him kind of go until everybody flipped over. It seems like the lift and shift robot won that match, even though we kind of let him stare. I was just amazed at what it looked like, because I've never seen him stand straight up like that. But it was super easy to put the batteries right back in, and we're ready for round 3 of this match. Ready? Go. Have at it. Go. Dope. I think they're stuck. Nope. They're fighting a little bit. There's a little movement. They're going. All right. Oh. I think they're pushing. They're locked but pushing. Now I see a track locked. Right here. That may cause a problem. They're still kind of creeping. Oh, the lift and shift bot is pushing. He's pushing. I don't see any signals off the mat, off the border yet. Although I see the lift, the lift on the SaneSmart robot. It may be changing the sensor signal. But I'm not ready to call it just yet. I'm gonna let them keep pushing. They're just pushing back and forth at this point. And I find that very, very different, because both their tracks are locked. The SaneSmart track got locked up here on the eye, and the lift and shift track on the back side here is actually locked on the little bolt that holds the track wheel on. As the ref on the side here, I see now that the SaneSmart bot has the blue light on one of the tracks, on one of the line sensors. So I'm gonna call it for the lift and shift bot. So I'm gonna come back and say that right here, this line sensor lit up and showed that he was off the mat. So we're gonna bring him back, as long as you can still see me. Hey there.
Yeah, you need to do a camera switch again.
No?
I need to catch up.
Oh, okay, cool. Yeah, that's what are you saying? It's like 5 seconds?
Yeah, maybe a little more now.
Okay. Oh, I wonder if I have to, every time I have to do the stream, I have to change that setting. Well, we'll see about it. But anyway, so we're gonna give that round to the lift and shift bot. The SaneSmart bot came off the track.
Yeah.
And at the last match, the other two were kind of locked up. And it could have gone either way. What I'm gonna do now is I'm gonna swap batteries with the... Actually, I'm going to swap all the batteries because I can do that, and it's easy and fast. They seem to be struggling to push, and as I take the batteries out, they're actually warm. Like the batteries have been struggling to keep up with the bigger robots. And yeah, both the batteries in both robots are very, very warm, and this is super cool because this swap is so easy. I've just taken out 6 batteries just like that, and I've got a pile of them ready. So while I'm swapping in batteries, I'm going to go back and I'm going to explain that there was a bit of the code right here that goes through this process of following the line. There's a black line you can see on the mat. And we've kind of developed this code that says that the robot needs to follow the line. And as long as the robot is following the line, they're free to kind of like put the moves on their opponent. And if they come off the line, they're going to flash a bunch of lights and play a tone and stop doing everything that they can. And I'll chat a little bit more about that in between the next match. But I wanna highlight this part that we were talking about designing, because we have 2 hacks for our robots, and hopefully Dave's taken the time to rewrite some code on the fly here. And while he's doing that, I'm snapping the robot batteries back into place, but I'm gonna hold up one of the robots here in just a second and show the difference in the code, or show the difference in their faces, because they have some different hardware, and it did not stop them from locking up. So we will come back to the table and draw more hardware over the next few weeks. Dun, dun, dun. But the batteries are very easy swap. And this will definitely show in the next match. The batteries look like they were dragging a bit and a little boring. I'm going to blame that on their what they were not doing. So I'm going to use the lift and shift bot. Wow, the motors are hot. The motors underneath are actually really warm. So they were struggling to move forward. They were locked up, as you saw, and even the batteries were hot. So that process of locking up draws a lot of power, because the motors have electricity that runs between like little magnets, and they push against the magnetic field, creating their own little magnetic field as the electricity goes in. It's electromotive force. I'm not going to bore anybody with the physics behind it, but yeah. So it can't move, so it creates energy in the form of heat instead, and that is very, very, very telling about the capabilities of the motors, and the draw on the battery. The batteries were drawing power, but my hunch is they were drawing back power at a lower voltage because they were old batteries. I left them in from last month because I wanted the battery change, because the battery change happened very, very quickly. But in the meantime, what I'm going to do is I'm going to chat a little bit about the hacks we made to this specific robot today. And one of them is the battery box. You can see the battery box right here is at the back of the robot. When you look at the robot up and down like this, you can see it's at the back of the robot, and it's not like that. We didn't buy the robot like this. The battery box goes in there, like under here, but you can't change the batteries if the battery box is under there. It's what I've learned. It takes 5 minutes. You have to take off this box here. You might even have to take this plate off right here just to get to the batteries, and the batteries fly out. We had this bot actually have one battery come out while he was on the mat. So you can see that having the batteries back here is helpful to us. And we just did a very quick, easy hack. We made this little plate that fits the dimensions of the bolt holes, and we moved the battery box so that it mounts on the plate, and the plate mounts in one of the old holes. Super easy, super awesome hack. I love it. I want to try to find a way to put it online and share it with everybody because it was super easy. It took like 30 minutes to print on an Ender 3 Creality brand printer. I think it literally took 40 minutes to print. Very, very easy. The second hack, and didn't work out so well. Didn't work as planned yet. We will see. We haven't seen that in real life yet solve the problem for us. But you can see here these robots will lock up. That I'm going to do a terrible job of showing you. Maybe I'll try to go back to the mat and show you over there, but I can't see the screen, so I don't know if I'm actually showing you or not. But anyway, let me show you on the SaneSmart robot. So the SaneSmart robot has this line sensor right here, and that's what we're using to keep track of where the robot is on the floor. And you can see on that match over there, there's this black strip of electrical tape on the floor, and these two little line sensors detect if the color underneath of it is dark or light. So that's how we keep the robots going forward and going after each other. And this is the sensor that says there's something in front of me. It transmits a sound like a dog whistle, and how fast it bounces back and forth is kind of how long it takes to bounce back and forth. That tells the robot like how far something is. And these two sensors kind of both stick out in the front of these robots. So if they climb up on each other, this one catches on the other one's face. So fast forward from last month, where our robots spent a lot of time locked up and in this weird kind of like sumo stance where they were stuck. We started designing parts and hacks for the Rangers to be able to stop that. And one was this. This one was the only one I had time to print. It took 30 minutes. It's a beak. It's supposed to be a beak. It's not really a beak. It's a little pyramid, but it's got this angled up face right here that will stop something from hitting it. So if our sensor here hit is going up, hopefully it goes up this way. And what we have not seen today is, I have not seen this, I'll point it out in the next match if it happens, but we haven't seen the sensor go straight up like this. What I have seen is the sensor go side to side. And I don't know, I haven't confirmed this, so I can't tell you if that this is actually working, but I was hoping that might happen here. These pyramid faces are angled to the sides, so if our robot can't push out, hopefully he's turning to the side, and that was the intention of this one. I actually dig Dave's design better. Dave found in Tinkercad, Dave found a helmet like a lacrosse helmet, like a football helmet, like the face mask, and that one is a challenge to print on a 3D printer. So I'm trying to sort out how I'm going to print it, but I want that looks so cool when if you join us for our Steam engine, our Thursday night kind of like 3D printing, robot hacking, and everything else. There's this sample of it, so it was super cool, and I dig it. But in any case, I'm not going to change the code for the lift and shift Ranger today. But I'm gonna let Dave do his best to come up with a new set of code, to edit his code on the fly while I've been chatting here, changing batteries, showing 3D printed parts and the hacks that we made. Hopefully Dave has been editing his code on the fly so that the SaneSmart robot will be able to crush things in the next round or the next match. I gotta come up with a better name for those. Did I miss your file?
I already sent mine.
Yes. Okay. Cool. So I'm gonna download. I'm gonna click download in our screen. It gives me this security issue. I'm still gonna download it. And thank you for renaming it Dave 2.
Yeah.
I'm gonna unpin me now, so at least it's both of us chatting. I just realized that so far it's been only my face, but yeah. So the way Zoom works is in our Zoom meeting, whoever on my screen it has the sound control. It's kind of like in a meeting, if you have the ball, you're allowed to talk. So in Zoom, whoever's talking gets the highlighted screen. So most of the time it's going to be me. I just run my mouth. That's what I do. But Dave, when I unpin me, Dave is free to chime in and share. So I'm gonna leave it unpinned for the rest of the matches, and we're gonna find Dave's file. I'm gonna put it in our folder, and now I'm gonna open our I'm gonna switch screens. I'm gonna show everybody what's up. So this was Dave's original file. This is Dave's control for the robot, and I'm not gonna I'll get into it in between the next matches. I'll kind of share things, but instead I'm gonna open up from my computer Dave's new file. I'm not gonna save Dave's old file because I have a copy of it. We're gonna open up here's Dave's new set of instructions for his robot. And I say set of instructions because these are blocks. It's not really code, but I'm gonna connect. I'm gonna come back here. We're gonna connect the Sane Smart Robot. Ready? Here we go. I'm gonna grab it underneath because the wheels are gonna run. So I'm gonna plug it in. And plugging it in gives power. You can see some of the lights coming on. Gives power to the brain, the motherboard. I'm gonna hit the button to turn it on. You can see it. The wheels wind and wind and wind. So I'm just gonna hold it to the side here. We're gonna go back. I'm gonna connect to it now. So we're gonna connect on COM 6, right there. Gonna connect, and you can hear it pause for a minute. It's connected, and now we're gonna upload Dave's file. I'm gonna take a quick peek just to make sure. We got it pauses 2 seconds. It looks like it does everything it's supposed to do. Oh, battery just flew out. So I'm gonna grab that battery.
So batteries fall out even.
Yes. Well, I was kind of holding it upside down, kind of like bobbing back and forth because I'm a nervous mess all the 24/7. But yes. So battery popped out, and I'm pushing it back in. Oh, it's one of the middle batteries too, which is hard, but not that hard. All right, cool. So there we go. Connected. We're gonna upload. So now we can see the upload process. Everything is working out. Arduino compiled it. The file is good. We can come back. Hey, hi, how you doing? Robot is still going. I'm gonna turn the power off now that we know everything has worked out for us. Unplug. You can hear the thing. I'm gonna turn up my sound a little bit because I realized my sound is very, very, very low. There we go. Maybe I can.
The audio sounds great on the stream. I don't know if I'm coming through on the stream yet. I haven't heard myself.
I see your. We're going back and forth. In fact, that's where the echo might be coming from. I have two mics set up. I should just be leaving it alone, maybe.
Yeah, there now. Now it came through.
Super. Maybe I turn off my microphone, my blue mic. Now. Okay, cool. Awesome. There we go. So we're gonna head back to there, and we're gonna have round 2. So we're gonna do best 2 out of 3 with the lift and shift bot and the Sane Smart bot, and I'm psyched for this. So let's get it. They got new batteries, and the Sane Smart bot has a new set of code, and I need to change back. So here goes the lift and shift bot and the Sane Smart bot. I'm gonna get right down here with them. Ready to run? Let's do it. Go. There's their 2-second pause. Go. Look at him. Oh, no. The lift and shift the lift and shift bot won. Oh my gosh, but that was amazing. That was probably the coolest display so far of the code. Because the Sane Smart bot backed up, did a couple moves and things, and left. That was that was cool as far as like being a nerd and all in with the code. All right.
Yeah, not quite how I wanted that to run, but we'll run with it.
That's cool. That's cool. I dig it. And you could definitely tell the difference between the batteries. But we're gonna go again. Ready? Best 2 out of 3. Go. And they're off. Oh! Look at that! Yeah, we pushed him right off. How did that? We're gonna stop him. We're gonna stop him. they're bending my arena. It got caught. It's caught on the lamp over here. They couldn't go any further because they pushed right up against the lamp. I've got a lamp over there, and it's just outside the arena that you can't see. But the lift and shift bot pinned the SaintSmart bot up against the lamp. Actually, up against the sidewall, but the sidewall is pinned up against the lamp. And neither of them flashed their lights to say that they lost. And we've kind of discussed that. I'm gonna chat about that in between the break when I stare at the code. So we're giving 2 out of 3 already to the lift and shift bot. But let's do round 3. Let's see what happens. Ready? Go. Get it. Oh, battery popped right out. Did you see that? And I dig the code from the SaintSmart bot, but did you see the battery shot straight into the air?
Oh.
That is amazing. I'm like super impressed at that round completely. That was quality stuff right there. But we're gonna come back to the table, and we're gonna give Dave the chance to change up some of his code. That was amazing. I'm not too much in the way, am I? When I'm down there?
No.
Okay, cool. So, can I do the replay? I just found a replay button, so I'm gonna mash the replay button quickly and see what happens. Oh, it does. It's not the replay button I thought it was gonna be. Nope. Oh, I need to make a controller for this. When my keyboard's up here, I can't control the replay. I just put 2 and 2 together. Okay, cool. So what just happened? The lift and shift bot took 2 out of 3, and batteries were flying, and the SaintSmart bot did some really cool stuff. So let's take a look at it. So we saw the SaintSmart bot flashed his lights, and that was to indicate that he was the loser. So I'm going to check it out. We're going to come over to the code block. Dave's going to be writing a new code to try to beat the lift and shift bot for this next round. But while he's doing that, and feel free to tell me I'm not paying attention, Dave, if you beat me done.
No, you're good.
Cool. But let's check it out here. So let's take a peek at some of the code and how it goes. So obviously down here at the bottom, I'm going to zoom in on this, and we're going to take a peek. This is the end of the code. You can see there's this word "stop moving" down here, stop all. So we've set it up, the blocks of code, so that you can just add your moves into it. These are like kind of like pre-programmed for us, the blocks, and we share the file. And you can add your own instructions, like this one here that Dave added. This turn right block right here, and we'll come back to that. But like when you can't do anything else, when your robot is done, he's gonna light up these colors and sound a beep and stop moving, and that's how we know who the loser is supposed to be. So you'll notice that doesn't happen all the time. It happened probably about 1/3 of the time. So we're gonna go up here, and we're going to take a peek at some of the line sensing code, some of the blocks. So if you look at this line right here, I'm going to shrink this down just a tiny bit so we can see it all in the one screen. This block right here says wait until line sensor port 9 detects all being black. So let me come back up here, and I'm gonna share a little tidbit with how this sensor works. So there are 2 sensors here. And what it does is it shines a light down that we can't see. It's like a dog whistle kind of thing. It's infrared light, just like your remote controls. Like if you have a TV, your remote control is probably using infrared light to send a signal to your TV. You can't see it, I can't see it, but it's infrared light. So the same thing here. There are two line sensors right here, and they send a signal down on the ground, and it bounces back up. And this part checks it and says, is it all being reflected back or not? And because of physics and chemistry, or probably chemistry, if colors reflect different lights back, so light colors and dark colors will cause a different kind of reflection, and that's what these sensors use to do that. And if I turn this on, you're going to see it in the camera. Watch this. This is my favorite part about doing all this. So that's the lights right there, and I'm going to turn it off real quick because it's going to go crazy. But the camera, my webcam right now, like the camera that I'm looking at, the one that I'm staring right into, can pick up that kind of light, but my eyes can't. So it's just kind of cool that I like to show that, and I like to say that. So it's a cool little nerdy thing. But that light shines down and back, and what we're noticing here is that we're looking for a certain condition, with no light being reflected back, and if you move down further into the blocks, we changed it so that it's looking for either all white or all black underneath of it. But if I hold the robot this way, and you see the back and forth, this comes back and forth straight here, the light shining, it's a 90-degree angle. So as the robots fight each other and they tilt, the light is all of a sudden bouncing away from the robot and at a different angle. So sometimes these sensors are not picking up the color underneath of it because it's not reflecting back at the little light. And that's it's not a flaw with the robot, it's not a flaw with the code, it's a flaw with geometry and the fact that this needs to bounce back right at it. We can get into really complex things like trigonometry and Pythagorean theorem and equations for squares and circles and spheres and all that stuff. But what it really comes down to is that not all the time, not in every condition, will our robots be able to tell whether the line under it is black or white. And that's cool for us, because behind the scenes we have coded things into these robots, and we can see them and we can see it, whether the code is working or not. And we're actually discussing behind the scenes how we write more advanced code so that we can stop this from happening, so that the sensors are more child-proof, I like to say, mostly for my benefit, because if it's child-proof, I can't use it. But so the idea is that the hardware is there, and it's only doing what it's told. So if I'm a soldier, on the battlefield, and you tell me to charge ahead, I'm gonna put my little blinders on and I'm gonna charge ahead. I'm not gonna try to do whatever they're doing over there to the left or the right, because I know my mission is to charge ahead. So these robots are much like any soldier in real life on a battlefield, any Call of Duty, Halo, Steve on Minecraft, and any of those characters that you control. It's this robot is the same way. There's a little block of code here that you can tell it what to do and kind of say, do this, do that. But then we're stuck with the hardware, and maybe that means we need a new sensor. Maybe that means we can work through the different parts of code and say that this code works or that code works, and we have to change the other part of code. So if we go back to the screen here, you can see that there are options in here, so we can detect none being black, or a left or a right being black. And you saw on my sensor, if we come back here, there is a left and a right. So there are two different sensors, and we can tell if we're going off a black line to the right or to the left. And that is what this code does. That's how the code that we've set up. You can kind of see it here. it detects whether it's got a white, if it sees white on the left or right, and it turns to the right or left. And for us, the actual code for the fighting comes, it's all these blue blocks here that I can drag in and out, but they happen after this sensor, after the ultrasonic sensor here detects an object closer than 10 centimeters. So we can zoom in a little bit more on this, and I can show you. If I can grab a good spot right here, so you can see ultrasonic sensor port 10 detects a distance less than 10 centimeters. So our robots actually are set up so that they follow the line. These robots are set up so that they follow the line. They follow the black line and stay on the black line until they see an object in front of it, and that object is their opponent. And once they see their opponent, then they start this list of moves and try to push the other one off the line. And that's the objective of the sumo battle. That's the challenge here, is that I've set up a block of code for the lift and shift robot that says I want to shake and bake. I want to put the moves on when I see my opponent in front of me. And Dave on the other side is also doing the same thing. When the Sane Smart robot is on the black line and the Sane Smart robot finds the opponent in front of him, he's gonna put the moves on and try to push the lift and shift bot off the line. If the robots go off the line, they're supposed to flash the lights, and that comes back to some of the sensors that I just mentioned not being in the same spot underneath of it. Maybe one robot is lifted up so that the angle is not 90 degrees anymore. Maybe that angle is different from 90 degrees, and all of a sudden the light is not reflecting back. So there's some changes and some things that we can work on with the hardware we have to try to change the code and make things more interesting for us. But that's more advanced coding, and right now we're still at the kind of like beginner. This is we're having fun. You saw the battery shoot straight up. That was really really funny.
New code's been sent.
Cool. I saw it just pop up. But so we're gonna get back into this part where I'm gonna plug in the Sane Smart robot here. Actually, first we will go back. I will download Dave's code. Dave number 3 right there. Cool. We will drop it in the folder, and this takes no time. There it is. It's done. We've done this. I dig the fact that we can do this over Zoom. We can do this from hundreds of miles away, and our robots are actually duking it out. I'm a little irritated about the lag, but we'll come up with a solution for that. I think maybe Twitch, maybe ditching Streamlabs for Twitch Studio will give us a better experience there for these things. That's next on the list to try. I'll have to check latency settings, I think, in Streamlabs and see if that works out or not. But we're gonna come back to. I was gonna upload code. Here we go. So let's get into the code. I'm gonna plug in the Sane Smart robot and power him up because I want the power on just in case the USB power is not enough to engage the memory. I'm gonna turn his power on. Ignore my winding. We're gonna connect. Oh no, wait, first I have to open Dave's file. So we're gonna open Dave's third file. And here we go. We're gonna check it out just quick. We've got this wait 2 seconds thing. That lets me get my hands out of the way. And then there's all this other code, ultrasonic sensor, and the lights light up after everything is done detecting. We're gonna connect to our Sane Smart bot. There we go. We know things are happening. Over on my end, the lights are flashing. We're gonna upload Dave's code. Right here, we are uploading Dave's code from the other side of New York into the Sane Smart bot. Everything worked out. It worked all right. I'm gonna turn the Sane Smart bot off. We're gonna unplug him. And now we're ready for round 3. Cool. So now we're ready for round 3. I'm gonna come back just real quick. I'm gonna head back over to that match, that round. Hey, hi, and let's get it. Come on with me. Here we go. We have got the lift and shift bot ready to go. We have got the Sane Smart bot ready to go. And I will note that on the left side is the lift and shift bot with our little beak add-on. So if we see the Sane Smart bot flipping over more frequently, we might be able to attribute it to the beak and the face guard. If we see them locking up, then we know it's not working as well as it should be. But the change in the batteries is a big help, because they don't stay locked up for long. But we're gonna get it. So match 1, round 3. Ready? Let's get it. Go. Oh, and they're off. And they're stuck. They're locked. No. Oh, whoa, that was crazy. So we just saw all the code happen all at once. The lift and shift bot backed off after he won. The Sane Smart bot took a roll. I'm gonna put the batteries back in right away and check out how easy this is. This used to take 5 minutes. And now we're down to, what, 30 seconds? So that's a massive improvement. And you can see over in the corner, the lift and shift bot has no line under it where it's already decided it's lost, but it didn't know that the Sane Smart bot lost first. So we're back for, I'm gonna turn them both off so their code can reset, they can start following the new set of instructions. And we're gonna go with round 2. Or match 2 of round 3. Ready? Go. Oh, and he flipped right over. I think he caught the nose cone, and now he's gonna go over. You are obnoxious, sir. And I'm gonna have to put you in the corner. I'm gonna have to go back and look at the slow motion replay, but I think this nose cone on the lift and shift bot actually played out just how it was supposed to work. So the Sane Smart bot flipped, and then flipped immediately, and it looked like he went right up the nose cone. But I'm gonna have to maybe tonight I'll dig into the replay and see if I can zoom in and see if that was actually the case. So we're gonna give it to the lift and shift bot, but that may be an unfair advantage because he's got the nose cone. All right, we're gonna head to the last match here. Ready? Go. Oh, batteries popped out. Did you see that? Everything just happened all at once. This battery thing is crazy. Moving the battery box has the batteries shooting straight up in the air. You can see them shooting straight up in the air now, so it's really funny to me. But all the code worked and all the code happened, and I find that really, really interesting. So the lift and shift bot, caught his opponent and put on moves because he was partially off the black line, and part of his move when he's off the black line is to back up in the zigzag pattern. So I'm going to bring the robots back and let's chat a little bit about what actually happened. Hi, hey, how you doing? Cool. So we are closing in on an hour, but I want to do one more match. Do you have time for another match, Dave?
Yeah, I'm good.
All right, cool. Let's do another match, and I want to chat through what I saw right there, because what happened a couple times was the robots are following through on their moves, their code, and they're coming off the line themselves as part of like their shake and bake. So first, the batteries are popping out, and the batteries popping out is even funnier now.
Yeah, absolutely.
Because you can see.
It just kind of sucks with me trying to listen to everything over here on our Zoom.
Yep.
And watching our Twitch is it's killing me.
Yeah. Let's.
I hear everything here, and then I've got to wait for the video to catch up. So I'm trying not to react at the time because it's not Right, you know what I'm saying?
I got you. Maybe turn one of them off and just you can give me a like a replay for now. Like what did you see that worked good and
I
bad?
could definitely tell it looked like the Sane Smart came in and went right up the nose cone on that last one, like we were planning. And the battery on that last one, I think it was in to make the connection, but not in enough. When that impacted, just kind of bumped it out. Let's see what else. What I'm trying to do with the code, what I want in the code is not working the way I want it to. I've got it in my mind, but I'm not processing it to the code the way I want it to actually work out what we're doing.
All right, that's all. That's all. How about we, like, I was going to mention the code too, and while you're talking about it, that's one of the flaws about these battery boxes is the batteries don't sit very well in them. You can kind of see, like, I can push them down, and they like pop back up. So popping out of the box is going to be something that happens for us.
Yeah.
And I think we like it makes us chuckle. So
of course.
So I don't see the pressure to kind of like make something that holds the batteries in. I think it's kind of funny, but yeah. So I did want to mention the code, and I'll let you talk through what you, first before you go and try to like change some of your code. What did you want it to do? Did you have?
So my goal with it is that because we're always going forward, I need it to reset itself and then continue that mission forward. And it doesn't seem that I'm getting it where I need it to be. Where it did back up earlier on, I don't know which backup that was. So thankfully I've saved each individual edition, every edit to its own file, so that I can go back and look at each individual one. Because I wanted, like I said, back up, go forward again. Maybe we may have to go with a wider tape to see if we can get it to turn and push the other off. How much tape do you have down on the floor? Because I'm not sure how much that is. About how wide?
Those are excellent comments and observations. The tape is 1.5 inches wide electrical tape, and I've got two strips down, so it's just under 3 inches because they overlap a little bit. So it's wide, like I want to say 2.5 inches or so. And I see what you're going at. If you want to dig into one last block of code, and we'll do one final best 2 out of 3. But I'm with you on some of the code. I feel like our code is based on the line sensor, and less on the object in front of you. And when the line,
I think that's what we're doing a lot of is less.
Yes.
It's doing more of the line sensor than it is the actual ultrasonic sensor, because obviously they're going straight at it anyway.
Yes. So here's my take as an engineer is that we're not using all of the sensors, and we're not adding all the code from everything else. That we're gonna get into something more advanced. And I mentioned this. I know I've mentioned it to you, but probably not in like a stream or anything. But right now, if we were setting a difficulty level on Battle of the Bots, right today it's like beginner, and we're talking about the things that we're gonna do at like the medium level and hard level, and like you're gonna die. Hope you have enough extra lives, kind of levels. But for me, the additional difficulty comes from adding more sensors into the code blocks. And you are correct. The first thing we can do now is to start going back and structuring our code so that we're using the sensor to pick up the best signal from the line sensor so far, and we may have it looking for a black when it needs to be white, and that will change how it looks at the floor. Excuse me. Throughout, so maybe this week or next week we can look at the code again and do another experiment where we take the sensors off and put it down on black surfaces and white surfaces and figure that part out. The other thing we don't do, you are 100% correct, is we do not use the sonar, the radar, the object detection.
Yeah, we have it in the code.
Yes.
But I don't think it's working the way we want it to, because obviously we're going head on anyway.
I will.
We could probably eliminate that piece of the code.
I will say that it works based on the lift and shift code, and I in fact I can open that right now, and I'll show you. I'll show you what happens. So, if I open the lift and shift code and look at it right here, you can see that the lift and shift bot, when it starts, is only moving forward. Oh, let me change my screen here. Okay, so back on this screen here, the lift and shift bot initially starts moving forward at 50% power. So when the match starts, you may notice that the lift and shift bot looks like it's going much slower. And that was intentional on my part because I wanted to see the code. So it's not until down here when he detects an object that he steps his speed up to 100%. So if you look at the difference right here between these two blocks, you can see that I used the ultrasonic sensor to kind of as the defining factor. Like, I'm just moseying down the black line until I see something to fight. Then I'm like all in. I'm full power, and you can see that in the code because it's for me it's set to 10 centimeters, so they have to get within like 4 inches of each other, and that's where the lift and shift bot will pick up speed. And now that you know that, now that I pointed out, you'll see it in another match, and so that part is working, and I did that because. We could just come back here. I did that because we in person use a different robot. It's the M-Bot robot, which is the little brother to the Ranger. And when we do this in person with the smaller robots, they have a different center of gravity and they do wheelies and things. If you can like make them jerk around like that, and changing the power was one of the things that we would do in the live events to kind of make them pop a wheelie and jump up. So I did this originally because I wanted to see if I could make the Ranger like pop a wheelie also, but I'm unsuccessful so far, and I was hoping moving the battery box back would be like change the center of gravity enough so that I could get him to pop a wheelie, but it has not popped a wheelie yet, and I'm a little disappointed. But yeah, so just back to the code, you are correct in the fact that we're not using that sensor enough, and we're not using other sensors enough. We had a workshop last week, you and I, where we were looking at the gyroscope sensor. So the gyroscope is something that can tell when the direction the M-Bot is going in. And I'm just going to come back here and say that when we get to when we move beyond the beginner difficulty level into like medium and hard, and why did I pick this? The gyroscopic sensor in here can detect movements on 3 axes, so X, Y, and Z. So as this robot tilts up like this, we can detect that also, and that's actually like a big step forward in our battle. But as far as the like beginner level, we're going to stick with the line sensor for now, and hopefully maybe next month or the month after we'll toss in some structure around some of the other sensors. I didn't want to get into it now because it starts to create the advanced difficulty levels, like I said. But in the meantime, we can work on perfecting this line sensor And what you will see from the lift and shift bot today and last month and possibly even next month is I have in here also code that says if he's within, if he detects his bad guy, if he's has the the fighter. Let me come back to this screen. If he once he detects his fighter, he looks at the line sensor differently. So up here, he was just kind of moseying along at about 50%. While before he found a robot to fight. After he finds the robot to fight, if he's going off one of the lines, his tactic is to back up, and it's a defense. And I'm going to describe it as a defense, because as long as he's all black on the line with an opponent, he's going to keep pushing forward at 100%. You can see it right here. But as this robot detects the fact that he's going right or left, he decides he's going to back up and turn left or right to try to get back onto the line. And I set these, and maybe these times here, turning backward and left for half a second or a quarter of a second is probably too long, because then he goes completely off the line. But the intent was I want to back up, and because I may lose this match if I go all the way off the line. So I want to kind of like pull back and regroup and figure out if I'm back on the line and then go forward again. Was how I talked through building this block of code for the lift and shift bot. And obviously that's backfiring a bit because he's taking off way too far back, and then he's off the line. And that's when all these lights pop on and off. So we've seen that in the process. So you've seen the lift and shift bot back up and do all this stuff and make all the changes and things. Excuse me. But yeah. So that's we come back here. That's just where we can tweak some of the settings. I didn't want to change the settings between last month and this month because it was working and it was doing what we can see. Like the movements are so big that we can see them in the code play out, and we can definitely tell from a troubleshooting standpoint is what's not helping us any is the line sensor and the reflection that's coming back up. This idea that the line sensor is detecting a line that's coming straight up and down, but as the robot lifts up and down, this angle here is no longer 90 degrees. So the light that's being reflected is no longer black or white detection. It's more like, is it there or not? And I think between now and next month, the best difficulty level setting we can make is restructure our blocks so that everything is looking for takes into account the angle. Like I said, we did that, and I can't remember. I can't remember like off the top of my head which way was the right way, but I feel like we had to change it so that it was looking for white, if I remember that correctly. But we can go back and look in a workshop next week. Next week was the like advanced coding thing what we'll do on Thursday. Yeah. We can dig more into how do we move beyond the beginner stuff. That's the plan. But keep snapping that code together. I'm not going to change mine for this match because I'm busy talking and yammering and stuff. But if you want another match, let's.
I'm good for another match. Let's just run that one again.
Okay, cool. Yeah, let's do it. All right. Yeah. So now that I've talked through some of the stuff, I'm gonna head back to the mat with the two beasts here. But yeah, now that I've kind of like pointed out some of the code and some of how it was supposed to work, watch your feed, and it's cool if you're the quiet one and I'm the one running my mouth. I'll come back to you and ask you 50 questions afterwards. So check it out and ignore me for a minute. We're getting into last match, round one. Ready? Go. see this, the scene looks devastating, but the lift and shift bot lost his batteries.
I would give that one to the lift and shift. I mean, the Smart flipped right over, and yeah, they both lost a battery, but I would definitely give that to lift and shift.
I think that's fair, but I almost want to say like the batteries came out at the same time. But okay, we'll give that to lift and shift. All right, ready? Best 2 out of 3. Go. And they're off. Once again, snap. And I don't know if the lift and shift bot still just... Oh, his batteries came out. All right. Again, looks devastating. I can slip these back. I love this battery box being right here. Look at that. I just slipped the batteries right back in. That was seconds. That was literally seconds. But you can see, now that we're talking about code and talking about, you know, how the actions are structured, you can see that the lift and shift bot is going slower, and they get so close that you can't tell when it's picking up speed, because 10 centimeters is like what, like this, I think. So until 10 centimeters happens, he's just here on the mat. He's not really here to fight someone. And as I slip these batteries right back in, I love this. This is so easy. I was so like flustered and struggling last month when batteries took 5 minutes to change. So batteries are in, and excuse me. And I also want to say that this last set of rounds, these robots have been like track to track, and the beak on the lift and shift bot, it will have a much bigger impact on what's happening. And that might be what's happened with both of these matches right here.
Yeah.
Cool. All right, so we're gonna do this last 2 out of 3. Ready? Go. Once again, I think that's hysterical. I think that's hysterical. Stop. Okay. So batteries flipped out again, once again. And I'm going to say that at this point, the beak had to be the contributing factor to this entire last match. Because they were straight on, tread to tread, and the only thing that it could be, and if I, right there, I don't know if you can see it or not, but that beak is perfect at like it is dead on the end of the, it works out to be dead on the end of that sensor right there, like that. I don't know if you can see it or not, but I'll bring it over to the table and show you. Sweet. Excuse me. It's almost time to get some water. So anyway, these robots did the same exact thing 3 times over, and what happens is the tracks are hitting track to track, not this way, not this way. And when that happens, one of them is going to start climbing on the other one. And what I just saw was this beak on the lift and shift bot is dead on the end of that sensor right there. And you probably can't see it too well, but the beak is actually what's stopping this from locking up like they used to do. And I think that is, well, obviously it gave the lift and shift bot an unfair advantage for that last match, but it's really kind of cool to know that the beak worked, and a little surprising. If you saw me design it, I threw it together in like 25 minutes, and I had no plans for the height. I did not realize it was going to be dead on, like accurate, and it's something I'll discuss next week. But anyway, so that was super cool. Dave, what'd you see in there?
Yeah, the codes were doing great, and like you said, the lift and shift probably had a unfair advantage. But unfortunately, the thing is, it's all about learning and making it better. with with the battery popping out. That last match there just kept going, and then finally the Saint Smart was rocked enough that it lost its battery. Yeah, I don't know anything else right now.
Cool. Yeah, that's definitely it. I dig it. I feel like this month was such a big improvement over last month as far as gameplay was concerned, or as far as like technical, like the robots doing their thing. Last month we spent a few matches locked up and a lot of downtime on battery swaps, and today battery swaps were a talking point, not a distraction. So
yes, very true. You had the batteries popped in within seconds, and we were back off and running again.
Yeah. So we're gonna end on that note, and I think this was super cool. We'll sort out some of the lag and some of the other things. Maybe we'll try a different app. Like I said, the Twitch Studio app. I'm juggling Zoom and the Streamlabs app right now, and I feel like between the two of them, there's a little bit of lag that maybe Twitch Studio will help with. But in the meantime, we can also figure out how we're going to print your helmet, because I want to see that. Like that just looks like you came to a robot battle with the helmet on. So yeah, I kind of want to see that. And I don't know. I think that's about it. I dig it. There was some good code, some good actions, and we got a chance to talk through what should have been happening. So it was cool to see it happen in that last match. And now we'll have to work out how we handle the unfair advantage of this little nose cone beak thing, and get it on more robots. But I think next month we add the M-bot. What do you think?
Yeah, why not?
All right, I'm down. Next month I'll build one of the M-bots, and we'll throw that in the mix. We'll bounce back and forth between only the Rangers and possibly the Ranger and the M-bot.
Yeah.
And we'll see if there's a difference between pushing one of these off the line, because the tactics are going to change. Obviously, the Ranger and the M-bot aren't going to hit track to track and flip over like they do. So the Ranger may need some new shake and bake moves. But yeah, that sounds fun, and I'm excited to see it. So I actually took Dave's suggestion here. I've got some credits and some stuff to show while Dave and I disappear and chat and figure out what we're going to do next. And in the meantime, thanks for watching. I'm going to close some windows here and switch to our little thank you and a highlight video from the last couple of years.